Good morning, Michael. You look like you're out on location again?
Yeah, Sam, that's right. I've escaped my home studio and I am standing next to one of the most powerful supercomputers in the world. How cool is that?
Wow. Okay, you've caught my interest. Tell me more about this supercomputer.
Well, Sam, this right here is Isambard AI, the UK's fastest supercomputer. I'm Michael Bird,
I'm Sam Jarrell.
and welcome to Technology Now from HPE. Well, Sam, I've come to moderately cloudy Bristol in the southwest of the United Kingdom to visit the most powerful supercomputer in the country. And this is a video episode. So if you want to see the supercomputer for yourself, make sure to check us out wherever you watch your podcasts, as well, of course, as wherever you listen to them.
And you absolutely should, because it looks really cool. And this episode is in two parts because there is far too much for us to cover in just one episode about Isambard AI. So today we are looking at the project itself, and next week we'll be looking into how you run something of this scale efficiently. Now, Michael, when we say it's the most powerful supercomputer in the UK, just how fast are we talking?
Great question, Sam. So Isambard AI is a modular data center, and it's run by the Bristol Centre for Supercomputing, who have said that it is the 11th fastest supercomputer in the world and the 9th fastest for public supercomputing. And get this, the internal network speed is a staggering 200 gigabits per second, which is about 2,000 times faster than the average home broadband speed of 100 megabits per second. And we have, as always, linked to these stats in the show notes.
Oh my, well, you certainly wouldn't have any lag while playing any games on an Isambard.
I don't think so.
So, Michael, who are you interviewing today?
Well, earlier on, I got a guided tour of Isambard AI from Professor Simon McIntosh-Smith, director of the Bristol Centre for Supercomputing, who has worked on this project since its inception. So, Simon, we are standing here at the entrance to Isambard AI. What exactly are we looking at here?
We're now inside the Isambard AI supercomputer compound.
Yeah.
You'll probably notice around you there's lots of physical security. So have lots of big fences, lots of barbed wire, loads of cameras. That's because what we're about to go in and see is one of the most powerful supercomputers anywhere in the world.
Wow. Okay. And what exactly is this project all about?
Well, Isambard AI is the first big part of the UK government's AI research resource programme, funded by the Department for Science, Innovation and Technology, DSIT. And it's providing a national resource for researchers and companies to be able to run their AI workloads at scale in the UK for the first time.
Amazing. All right. Well, let's make our way in. And so this is called Isambard AI. What exactly is it that we're about to go into?
The first thing you'll see is it's in what looks like a big metal box, and this is the purpose-built data center. It's actually a modular data center, which is a special kind of data center that's actually prefabricated off-site. And then it's brought here in different components and reassembled. We actually reassembled this whole data center in just 48 hours.
So this is part of the UK government's national AI strategy.
That's right. It's all funded by the Department for Science, Innovation and Technology, or DSIT. And they're investing hundreds of millions of pounds to ensure that the UK has access to the AI infrastructure, the AI capability that we need as a nation.
So what problem is Isambard AI solving that other computers or facilities around the UK can't?
Well, one of the things the government was really pressed to enable was the ability to train large language models in the UK and have a sovereign AI capability. So the compute would be here, the data would be here, the software would be here. And you needed a big enough supercomputer optimized for AI to do that. And so Isambard AI has actually got nearly 5,500 of the recent NVIDIA GPUs to enable that training of the largest large language models.
And you sort of alluded this, but this was built incredibly quickly.
So when the government realized this was going to be very important, they asked us, how quickly could you do it? And fortunately, we had a bit of a head start because we were already building a smaller general purpose supercomputer with HPE called Isambard 3. And for that, we were using a modular data center for the first time. And we actually built a whole site from scratch in just 4 months. So from a car park to a site with a data center on it and a computer in, passing all its tests in just 4 months. And for us, that was transformational. So we'd done that sort of thing in the past, and it had taken 3 or 4 years. To get that down to 3 or 4 months is absolutely transformational. So we pitched the idea of building Isambard AI using modular data centers so that we could do it very quickly. We already had the site, we already had the power here, and we knew the modular data center would let us do it fast. So in fact, the whole thing, start to finish, from digging the first hole in the ground for the site to putting the data center in, having the supercomputer inside it switched on, and in production, which means running real user problems, was just 14 months. That's 4 months, just over 1 year to do that.
And when you say modular data center, like how much of it is modular? You know, does this whole room just turn up on the back of a lorry, or?
Yeah. So the piece we're in was one big piece, and it came over on 6 giant trucks, actually sailed across the channel on the ferry, and then drove around the motorway to get here. So it was fully tested in the factory before it shipped. And then it could be reassembled incredibly quickly, just 2 days, 48 hours, to put the whole data center together on site.
All right, can we go and have a look inside?
Should we have a look?
Yeah, is that all right? Would you be able to open up one of these? I want to see what it
big
looks like
cabinets?
inside.
They look like big wardrobes, but inside, when I open up the doors, you'll see lots and lots of equipment. Now, we don't tend to have the flashing lights anymore like we used to on supercomputers of old, but instead you'll see there are lots and lots of pipes, and these are pipes, not cables, and they're blue and red, and that kind of gives you a hint as to what they're for. Now, all modern supercomputers at this scale are direct liquid cooled, so they produce so much heat, so they're using so much power, that the only way to cool them down effectively and keep the thing very compact is with water. So we actually have, this is water flowing around the system. It's a water glycol mix, actually. But that's keeping it cool. In fact, the blue pipes are the cool water coming in from outside, and you'll see that where that comes from later on. And the red pipes are the hot water coming back off the equipment, which goes back out to be
so
back down again.
There's a temperature difference. Can I feel the difference?
Well, even the blue pipe is, you can touch it. Even the blue pipes are warm. So in some ways, it's actually warm water cooling.
Yeah, okay.
Which I know sounds a bit like an oxymoron, but it is warm water. So it comes in warm, but it comes out even warmer. And it's just that temperature difference is the thing that's providing the cooling effect.
And so these are all individual blades.
Yes. So there are these big vertical metal structures, which if I were to pull one of those out, each one of those would have lots of GPUs on it. And the GPUs are the engine of an AI supercomputer. And there are 8 GPUs on each one of those blades. And there are 55 blades in each one of these cabinets. That's 440 GPUs in one cabinet. Now, they do use quite a lot of power to energize all of those. In fact, this one cabinet is about a third of a megawatt, 330 kilowatts.
So how many GPUs are in this whole facility? How many cabinets are there? How many GPUs in total?
We have 12 of these compute cabinets. There's 5,280 GPUs in this room. And this room is not very big. It's only 12 by 12 meters. But that can be up to 4 megawatts of computing power because it's so dense, enabled by that liquid cooling.
Yeah, this doesn't look like a sort of a server cabinet to what I'm expecting. You know, most server cabinets, the compute is sort of horizontal. This is all vertical. Is this just for absolute density?
This is for density. And in fact, what you can't see here, but on the back is all the networking. And the networking actually runs horizontally. And then these two kind of mesh together. The compute blades slide into and connect with the networking blades that are on the back. So that all that together is to give us this maximum density. One of these cabinets weighs 4,000 kilograms or 4 metric tons.
Wow.
So very, very dense.
And is the networking water cooled as well?
Absolutely everything is water cooled. In fact, you can't really tell, but it's very quiet. We're just having a normal conversation. Yeah. Very quiet in here. There's a very faint hum that's going on, but that's actually from the pumps that are pumping the water out. The networking is water cooled. Even the power supplies are water cooled. So there are no fans in here whatsoever.
Yeah, I'm quite used to a screaming data center, all the fans. This is quite a nice environment.
Yeah, you can be in here,
but it's not. It's not noisy.
We don't need ear protection or anything like that, and we can have a conversation.
Okay, so we have something behind us. Can we talk through what we have here?
Here we go. So we talked about those blades, those vertical structures that we pulled out of one of the cabinets, and this is what one of the blades looks like. So it's quite long. It's surprising, really, just how long this thing is. And you can see there are these interesting looking things with pipes on it. So it's 1, 2, 3, 4 GPUs here. And there's another 1, 2, 3, 4 on that end. And the 4 actually group together into one server, or we call them a node. So this is one node on one end and another node on the other end. And we've got 8 GPUs in total. Down the middle is where all the networking goes. There's actually one network endpoint for each GPU. So 8 GPUs, actually 8 network connections. Those are 200 gigabit HP slingshot for each one. So there's lots and lots of network connectivity. The pipes are where the water goes for the cooling.
And the pipes are bright green.
The pipes are green. It's actually the water has been dyed green deliberately in case there's a leak, which makes it much easier to spot. In fact, the dye also fluoresces under an artificial light. And you can see the copper plates with the little copper pipes. It's all part of the cooling loop, so that we can get the heat extracted from the GPUs into the water and outside to be cooled down again.
And you've told me that I can't touch this because this is probably worth more than my house.
One of these would get you a decent flat somewhere, absolutely. So these are very, very valuable things. But in the spirit of old-fashioned TV, here's one I prepared earlier. And we do have one of the GPUs. That one you can touch. That one doesn't work anymore.
So it's about the size of my tablet that I was holding moments ago. I mean, so much compute in here. And as you said, it's one of the fastest in the world.
Yeah, currently Isambard AI is actually ranked number 11 on the top 500, which is sort of the league table of international supercomputers. It's the most powerful in the UK by a long way today. There are other AI research resource computers coming and national supercomputers. But today, Isambard AI is about 10 times more powerful than the second most powerful computer in the country. So a lot of the UK's compute power is in this room right now.
What sort of projects being run on this system?
So we're now up to over 2,500 users and over 600 different projects all running on Isambard AI. And it's across a very wide range of anything you can imagine to do with AI. Some of the projects are, for example, training large language models, which might have a unique set of data going into them. So, for example, we have one project training a large language model based on UK legal case law and also other UK languages. So not just English, but also, say, Welsh and Scots Gaelic. So this training type project. There's lots of projects in sort of health space where we're looking at things like automatically analyzing images of moles on the skin to try and determine if they're cancerous or not. And lots of projects doing things like, can we automatically optimize or discover new kinds of drugs, which might be something that will treat cancer. It might be a vaccine. We've got some projects looking at vaccines for dementia. So this is the kind of thing, in 5 or 10 years' time, we might be able to go to the doctors and get a vaccine that will protect us from, say, Alzheimer's. And that was developed on Isambard today.
It's really exciting. So how do people come and run these projects?
The allocation process is actually run by the people who funded the system. So that's part of the UK government called DCIT. So they and UKRI, who's our National Research Council, they run regular calls. So they say, we're looking for projects in this kind of area. Please submit a proposal. Lots of researchers and companies as well, by the way, can submit proposals with their ideas. And if the government likes what they've suggested, they'll award them the time as a grant, so as a free grant on the system. And these have been anything from smaller projects, 10, 20, 50,000 GPU hours. We now have big projects being allocated on the system. They could be up to 1 million GPU hours. So that's the sort of thing that if you were buying that time in the cloud, that would be costing you millions of dollars. You can get that as a grant to run an exciting project on Isambard AI today.
And can you talk through any breakthroughs that have happened on the Isambard AI project?
I mentioned the project looking at pictures of skin cancer. It had a hypothesis that some of these algorithms had bias built in, that where they work better on paler skin and not so well on darker skin. And they've actually already proven that is the case. And they've already improved the training data so that it's more diverse, rerun the algorithms, and they've got a lot better. So one of the first breakthroughs that we've had was already starting to significantly improve how accurate these algorithms work on a wider range of skin color.
We talked about these GPUs and the technology here, but technology moves on very quickly.
It does.
So are you already thinking of what's next?
Yeah, I'm always thinking about what comes next. So Isambard AI is actually the 4th in the line of different supercomputers we've been building. We had Isambard 1, 2, and 3, now Isambard AI. We're already considering what would we do next. The government's very keen actually to try and get significantly more compute than this even for AI by 2030. So there's a lot more to come. And we've got space nearby and more power nearby where we could build even bigger versions of Isambard nearby very quickly. We're even considering things like different sorts of architecture that maybe will be optimized specifically for AI inference, and maybe not just everything running on the same GPUs, but different kinds of hardware, different kinds of problems. We've even got some early discussions about possible quantum computing projects that would be connected to AI in some way. So there's always something that we're thinking about for what will come next.
Could you just add more modules to this data center, assuming there was space?
In theory, you could. I mean, this one's really been designed as a specific size for a specific computer, but this approach of having modules, this one is essentially 4 modules wide with a module on the end for storage and other air-cooled equipment on the end. But you could have designed one that was 5, 6 modules wide. You can design them that are one module at a time, but you have them next to each other. And there are other sites that have been doing things like that. So it's a very flexible, very agile, very adaptable approach. It's kind of more flexible than a bricks and mortar building where once you built it, it's quite a big job to change it and knock a wall down and build extensions and things like that. So it's a very flexible, adaptable approach to using modular data centers.
Simon, thank you so much for your time. Thanks so much for showing us all of this incredible equipment. It's lovely to have you on Technology Now.
It's been a pleasure to be here and really nice to welcome into Isambard AI.
Wow, interesting discussion. First things first, though, Michael, I want to understand the mod pod a bit more. It's kind of fun to say, right? The mod pod. But from what I understand, this sets it apart from other supercomputers.
Yeah, I mean, as Simon said, it's a modular data center, so it can be built really, really quickly. So I think as Simon said in the interview, I think this was 13 months, 14 months to build it, and it would have taken about 3 years if it was sort of traditional bricks and mortar. But the whole thing is that you could just sort of spec it up. It essentially arrives on the back of a lorry. There's a bit more to it than that. And they sort of plonk it down and it's all modular. So it's just a much faster way of doing it. This was basically a car park before this data center appeared here. And yeah, I think it's just about the sheer speed. And I mean, the amount of power, the amount of GPUs and computing power just in this space, it's quite incredible.
11th fastest supercomputer in the world, but probably the fastest one, period, to put together, right?
Yeah, absolutely, yeah. So the cool thing is, and if I'll open this door again because I like that I can keep doing this. So yeah, as he said, so we have multiple blades in this rack. I think it was something like 55. I'm looking down to my producer, Harry, just to double check. 55, he gives me a thumbs up. So 55 blades in here. Each of the blades has 8 GPUs in them. They're all water cooled. So yeah, it's incredible. Every single little bit of technology has been thought about to really just hone and refine and make it as efficient as possible.
Do you know why the cooling liquid glows?
So I think they add it in. I think it's water with some special coolant in it. But I think they put the green dye in it so they can see it, so they can see if it's flowing, see if it's leaked.
It's kind of fun. It was very sci-fi.
It's very sci-fi looking.
I love that. I also really appreciated some of the discussion around what this supercomputer will actually be used for.
Yeah.
The main projects being the Multimodal Health Foundation model trained on the NHS data, and then the cancer screening. To me, that's the kind of stuff that you want to hear about supercomputing and AI actually doing to be a force for good in the world. But which one stood out to you?
Simon and I talked about the cancer screening. So screening for moles, that sort of cancer screening. So I'm guessing analyzing that image data. I just think that's cool. I think to your point, we want to be a force for good. And just to think that again, all of this stuff is changing the world. It's quite a humbling place to be, quite humbling to be stood next to it. And the fact that there are so many different projects running on this, it's only really been running for about 6 to 12 months, I think. So there's so much more opportunity, so much more that's going to come from this. Anyway, Sam, let me just say, we heard from Simon about how the project came to be and how it works. But looking forward, I also wanted to ask if there was anything that we should be looking out for in the future, any exciting announcements, that kind of thing.
For Isambard AI, I think we're literally only just starting. I think the most exciting projects that will run on this system haven't even been imagined yet. And in 5 years' time, we'll look back and think, boy, we were just scratching the surface there. Now look at what's been possible. I think there'll be some amazing breakthroughs for health. I think there'll be some amazing breakthroughs in science and engineering. We have some projects running doing amazing things in fintech. So I think we can't imagine today what will come out of it, but it's going to be very exciting.
Okay, that brings us to the end of Technology Now for this week. Thank you to our guest, Professor Simon McIntosh-Smith. And of course, to our listeners, thank you so much for joining us.
Yes, and if you've enjoyed this episode, please do let us know. Rate and review us wherever you listen to episodes. If you want to get in contact with us, send us an email to technologynow@hpu.com. And don't forget to subscribe so you can listen first every week. Technology Now is hosted by Sam Jarrell and myself, Michael Bird, and this episode was produced by Harry Lampert and Izzy Clark, with production support from Alicia Kempson-Taylor, Becky Bird, Alyssa Mitri, and Janessa Ayosh. Our video editor was Leon Roginski-Gorman, and our theme music was composed by Greg Hooper.
Our social editorial team is Rebecca Wissinger, Judy Ann Goldman, and Jacqueline Green. And our social media designers are Alejandra Garcia and Ambar Maldonado.
Technology Now is a Fresh Air production for Hewlett-Packard Enterprise, and we'll see you at the same time, the same place next week. Cheers.
Bye, y'all!